Hello and welcome to our high school GCSE video series. Today we're going to be looking at how to solve simultaneous equations by elimination. That's eliminating one of the variables, either x or y. So first of all, some terminology. What do we mean by simultaneous? It just means our equations are true at the same time. And we're going to be dealing with linear simultaneous equations, which just means if we were to plot each equation on a graph, we'll produce a straight line. And in terms of algebra, there are no x squared or x cubed or y squared or y cubed terms, just x terms and y terms. And the word coefficient is the number which appears directly in front of the x value or the y value. So our first example, we have an equation here where the coefficient for y is 2, the coefficient for x is 6, and then let's look at our second equation where we also have a coefficient of 2 for the y value, but the x coefficient is 4. So in this case the y coefficients are the same as each other. Now when the coefficients are the same, we can actually subtract the equations from each other in order to solve the problem. So we can take, for example, equation A, take away equation B. This will give us then 6x minus 4x gives us 2x. 2y, take away 2y gives us nothing. And 6 take away 2 gives us 4. So in other words, 2x is equal to 4. If we divide by 2, this will give us then that x is equal to 2. Now that we've found our x value being equal to 2, we need to substitute this back into either equation A or equation B in order to work out the corresponding y value. So which equation we choose is really up to us, but let's choose equation B. So that will give us then 4 times our x value of 2 plus 2y equals 2. So 8 plus 2y is equal to 2. If we then subtract 8 from both sides of that equation, that will give us 2y is equal to minus 6, so y is equal to minus 3. So our final answer for this problem is x is equal to 2 and y is equal to minus 3. Let's look at a second example. This time the x coefficient is 5, the y coefficient is 2, and for our second equation we've got a y coefficient of minus 2. So we've got a 2 and a minus 2 for the y coefficients. Now when you've got this situation, it means you can actually add the two equations together in order to eliminate y. So if we then add equation A to equation B, that will give us 5x plus 3x gives us 8x, 2y add minus 2y gives us nothing, and 16 plus 8 gives us 24. In other words, 8x equals 24. If we divide through by 8, that will give us then that x is equal to 3. So now that we've found that x is equal to 3, we need to substitute that back into either equation A or equation B because we need to find our y value. So in this case, let's substitute it into equation A. 5 times our x value of 3 plus 2y equals 16. So 15 plus 2y equals 16. Take away 15 from both sides gives us that 2y is equal to 1. So y is equal to a half, or if you prefer to work in decimals, y is equal to 0.5. So our final answer for this example is x equals to 3 and y equals a half. So our third example, we've got a x coefficient of 3, a y coefficient of 2. So that's our first equation, equation A. And for our second equation, we've got the situation where the none of the numbers are the same. So we've got a 4 for the x and we've got a minus 1 for the y in our equation B. So we need to do something to make the coefficients the same. So if we multiply equation B by 2, that will give us then 2 times 4x gives us 8x, 2 times minus y gives us minus 2y, 2 times 29 gives us 58. This means now we can add equation A to equation 2b, and this will then give us 3x plus 8x gives us 11x, positive 2y add negative 2y gives us nothing, and 19 plus 58 gives us our 77. So 11x equals 77, divided by 11 gives us that x is equal to 7. Now that we've found what x is equal to, we need to find out what y is, and we substitute x equals 7 back into either equation A or equation B. If we choose equation A, then we have 3 times 7 plus 2 times y equals 19, so 21 plus 2y equals 19. Take away 21, that will give us 2y equals minus 2. So our final answer is x equals 7 and y is equal to minus 1. So the 2y equals minus 2 was divided by 2, and that gave us our y is equal to minus 1. Giving us x equals 7, y equals minus 1. And we now look on to our fourth example, where we've got none of the x coefficients or the y coefficients are the same. So we need to do something about this in order to eliminate either the x values or the y values. So if we multiply the top equation A by 5, this will give us 10x, and if we multiply equation B by 2, that will also give us 10x, and that's good news because we can then subtract those values away from each other. 10x minus 10x gives us nothing. So let's do that. So the first equation, multiply throughout by 5, so 5 times 2x is 10x, 5 times 3y gives us 15y, 5 times 12 gives us 60. And then for equation B, 2 times 5x gives us 10x, 2 times 4y gives us 8y, and 2 times 23 gives us 46. If we now subtract those equations away from each other, 10x minus 10x gives us nothing, 15y take away 8y gives us 7y, and 60 minus 46 gives us 14. So 7y equals 14, divide by 7 gives us y equals 2. We now need to substitute that back into equation A or B. Let's choose equation A. So that will give us 2x plus 3 times 2 equals 12. So 2x plus 6 equals 12. 2x equals 6, x equals 3. So our final answer is x equals 3 and y equals 2. Well, thank you very much for watching, and I hope that's helped you with your maths solving simultaneous equations by the method of elimination.